Hello, you're welcome back to Quiver Analytics, and this is our non-parametric test series. Now, in this video, we want to discuss and demonstrate the Friedman test. Now, the Friedman test is synonymous to the repeated measures ANOVA, where we have the same participants um, being introduced to more than two interventions. The same number of participants, like we have column 1 here, we have participants 1, 2, 3, 4 to participant 100. Then we have time 1, probably first intervention at this time, the second intervention at this time, the third intervention at this time. The 3 interventions applied to each of the participants. That's data structure for the Friedman test. And what we want to test is that, is there a significant difference between these outcomes, the measured outcomes? So it is applicable in different fields. In medicine, for example, we might be applying 3 different types of drugs on the same participants for 3 different times, then to measure the outcome. In, say, in the workplace, we can expose workers to 3 different types of leadership, 3 different work environments, hostile, friendly, and different types of environments, and measure their productivity. In movies, we can um, we, we can expose viewers to 3 different types of horror movies, if there's anything like that, and see, probably measure their heartbeats after the movie, or war movies, and so on. Like, whatever your scenario is, the bottom line is that you have participants non-changing, all of them being introduced to the uh, the intervention, whatever, in at least more than 2 times. That's at least 3 times and beyond. Then we use the Friedman test. All right. So here we'll just be calling it time 1, time 2, time 3 for all of the participants. We are assuming that they were exposed to, say, movies, for example. They watched movie 1 at time 1, movie 2 at time 2, and movie 3, 3 different movies at 3 different times. And this is their rating. Let's call it rating. Probably rating of scale 1 to 10. I can see there are no 10 here. So the more reason we should do our descriptive analysis, frequencies, and we know the participants. We know the participants is just 1, 2. So statistics, we need the mean, we need the median, the maximum, standard deviation, okay, and the charts, the histogram, and this. Okay, let's leave the frequencies because we know it's between 1 and 10, like, so it's still okay to go for the frequencies. All right, so we have valid missing 96. How is that possible? Okay, blah blah blah. So we have frequency total is 100. Okay, I think I might know. Let's see, let's go back to the SPSS. No, because this is the same, so we have some dots here. Okay, so here I'm going to clear it. All right, then I go back because I've used previous data, like data longer than the previous one, the current one, so that's why it's saying those spaces as missing values. So frequencies, and run this again. So you can see we don't have missing values anymore. 0, 0, 0. Now the minimum is 5, maximum is 9, minimum is 5, maximum is 9. All right, okay, so let's see. Okay, they are quite distributed normally, and okay, yeah, so given the numbers that we have between 5 and 9, we really can't say that they are numeric. You can see SPSS has turned them into nominal. but they are actually, I mean, into nominal, but they are actually ordinal, because whoever graded 9 assumes that it is greater than, that it is much more interesting than what it would have given a 5. So, like I said, the intrinsic value of data also helps us to know what tests to use. All right. Um, okay. Knowing that, we go straight to analyze non-parametric tests, legacy dialog, and we have k-related samples. So we bring the 3 here. You can see it's already on Friedman, and statistics, descriptives, quartiles. I'm not choosing anything here, so continue and okay. All right, so test statistics, we have 0.521. That means there are no, the test is not significant. That means there are no significant difference between the outcomes of these 3 movies, the ratings of these 3 movies. There might be differences, there might be disparities, but disparities are not significant. That the fact that um, participants 1 rated movie 1 8, rated movie 2 8, and rated movie 3 6, it does not mean that there's a whole lot of differences there. 9 5 7 7 8 5, you can see. So given this outcome, let me go back to the outcome. You can say that there are no significant differences. The average mean is 7 6, I mean almost 7, like 7 6.9 is approximately 7, 6.8 is also approximately 7. You can see the standard deviation 1.4, 1.4, and approximately 1.4. So indeed we can say there is no significant difference in the ratings in this movie. Right, the ratings in this movie, in these movies, are not significantly different. All right, so that's basically how to interpret, to run and interpret the Friedman tests. All right, thank you. Don't forget to subscribe and like our videos, and follow us on all of our social media pages, Quiver Analytics. Thank you, and see you in the next video.